Hi students, so let us continue our relations topic from the previous class. In the previous class we have discussed how the relation is going to be defined, but we have not written the definition of relations. We have just introduced how the relation is going to be defined if there is a Cartesian product. Clear? Okay. So a relation from non-empty set A to non-empty set B is a subset of Cartesian product A cross B. Full point. Here what happens, a relation from first element to second element are given by the sets A and B. Clear? So you please remember that a relation is defined as a subset of Cartesian product A cross B. Clear? So now let us write the definition of relations. Okay students, to write the definition you can pause the video and you can write down it, no problem. But before writing that definition, first let us understand the relations definition in clear. That is, a relation R from a non-empty set A to non-empty set B. That means relation R is defined between two non-empty sets. This is very, very important. Clear? So this you must understand in the definition. Clear? If the relation has to exist, the both sets must be non-empty. Clear? So R is defined between two non-empty sets, that is A and B, such that, see here, a relation R from a non-empty set A to non-empty set B is a subset of Cartesian product A cross B. As I said, relation is a subset of Cartesian product. That's what the same thing we are telling here. Clear? Is a subset of Cartesian product A cross B. The subset is derived. Please understand this. The subset is derived by describing a relationship between first element and the second element of the ordered pairs in A cross B. Clear? Whenever you are defining a relation, it should be a subset of Cartesian product, and as well as there must be a relationship between the first element and the second element. You see my previous video. In that video, I have explained one relation which is a subset of Cartesian product, where in the first set you were having A, B, C, 3 alphabets, and in the second set Q you were having 5 names. Clear? We have defined a relation from set P to set Q, which is a subset of P cross Q. If you understand that, here the definition will be very much clear. Okay. The first point is A and B sets must be non-empty, and the second point is the relation must be a subset of Cartesian product, and the third point is there must be a relation from the first element to the second element of the order pair in A cross B. Are you getting my point? These three elements or these 3 points are very, very important. The first one is A and B must be non-empty sets. Second point is the relationship must be a subset of Cartesian product, and the third point is there must be a relation from the first element to the second element in the order pairs of A cross B. Clear? Next, the second element is called image of first element. No problem. In the order pair, see, x comma y, we say that the second element y is the image of x. Yesterday I have explained with the diagram like this. Here you are going to have the first element, here you are going to have the second element. So these second elements are called the images of first element. The second elements are called images of the first element. Clear? So in that way we define a relationship from non-empty set A to non-empty set B. So you can pause the video to write down this definition already I think you have understood this definition. Clear? So please write this by pausing the video, take down the notes, no problem. So but remember that 3 points, that is a relationship is between two non-empty sets. Second point, relationship is a subset of Cartesian product. And third point is relationship is a relation from first element to the second element of the given order pair in A cross B. Clear? Okay students, take it students. By understanding the relationship between set non-empty set A to non-empty set B, now let us go to the further definitions, that domain, range, codomain. Clear? So when you define a relation, with that relation these three are going to be exist. Clear? For example, let us take one of the relation as r equal to a comma 1, a comma 2 or b comma 2, c comma 3. Clear? Where the two sets are set A equal to a comma b comma c and set b equal to 1, 2, 3, 4. Clear? So to understand this, I am taking one example. I am taking an example of relation such that A and B must be two non-empty sets. So A is a set of A comma B comma C, B is in a set of 1 comma 2 comma 3 comma 4. So whenever you are writing in a relation, two non-empty sets are very important. Without two non-empty sets you can't write relation, because relation is a subset of Cartesian product A cross B. Are you getting my point? So for that reason I am choosing A as A comma B comma C, B as 1 comma 2 comma 3 comma 4 as two sets. Then I define relation A comma 1, B comma 2, C comma 3. Okay, no problem. If you draw it in mapping form, see this A, B, C. Here you are going to have 1, 2, 3 and 4. A maps to 1, B maps to 2, C maps to 3. This is set A, this is set B. Clear? Okay. Now, we have taken one relation. Already we have written the definition in this video of the starting. Clear? So here there is an example, that is A is a set of A comma B comma C, B is set of 1 comma 2 comma 3 comma 4. If I define a relation with the order pair A comma 1, B comma 2, C comma 3, everything is over about relation. Now in this there is a domain, there is a range and there is a codomain. Clear? Please understand, that is domain means the set of all elements or the set of first elements, the set of first elements in the order pair, in the ordered pair of A cross B in the relation from A to B, in the relation from A to B. That means domain is the set of first elements. The domain is the set of first elements in the order pair of A cross B in the relation from A to B. That means, see here, there is a relation R. If you want to write the domain of this relation R, what you have to do? You have to collect the set of first elements. The set of first elements. That means domain of this R, domain of R is equal to, see what you will get, collection of first elements of the order pair. A is the first element, here B is the first element, C is the first element. So A comma B comma C. So this is the domain of relation R in the given example. Clear? Okay. Next, range. Range is again the set of all second elements. The set of all second elements in the order pair, in the ordered pair or ordered pairs of A cross B, of A cross B, of the relation from A to B, from A to B. Clear? So that means in the domain you collect the first elements, in the range you collect the second element. Clear? See what they tell in the range, the set of all second elements, the set of all second elements in the order pairs of A cross B of the relation from A to B. Already there is a relation for this A and B. Clear? This R is going to be a subset of A cross B for this relation, for this Cartesian product. Okay. So now if I want to write the range of R is equal to, range of R is equal to what? The set of all second elements. What are the second elements? 1, 2, 3. So that is 1, 2, 3 is your range of R. Clear? Therefore, domain is the set of collections of first element. Range is the set of collection of second element of the order pairs A cross B for the defined relation or for the given relation from A to B. Clear? So therefore, I think with this example, this definition is very much clear for you. Okay? You can pause the video to take all these notes, or otherwise there is a PDF which I have already sent you. From that you can write the notes also. But to understand what is domain and what is range, the first important thing is domain is the set of all first elements of the order pairs. Range is the set of all second elements of the order pairs. Clear? For the relation from A to B. For the relation from A to B. For writing these definitions, please don't write only the set of all second elements. You have to write complete this all statements. Then only the definition will be correct. For our understanding, we say the set of all second elements. For our understanding, we say the set of all first elements. But whenever you are writing the definition in the exam, all these 3 lines should be written. Here also all these 3 lines should be written. Okay? Then only you will get the complete marks. Okay? Codomain means the set B. The complete set B is called codomain. Anyways, complete set A is called range. Complete set A is called domain. Are you getting my point? So codomain is your set B in the A cross B. Clear? Codomain is a defined set B in A cross B. Clear? Okay. Pause this video and take the notes. So now let us solve one of the example on the definitions which we have already studied. Clear? Okay, what is example here? Let A be the given set. Let A be the given set of 1, 2, 3, 4, 5 and 6. Define a relation R from A to A. Define a relation R from A to A by R equal to order pair x comma y such that y equal to x plus 1. Clear? That means they are defining this relation R as order pairs x comma y such that y equal to x plus 1. So this relation you have to first solve before going to these 2 things. Are you getting my point? So first you have to solve this relation. After solving this relation, first question is, depict the relation using an arrow diagram. So by using an arrow diagram, you have to write this relation. Clear? Already what is arrow diagram we have discussed. No problem. Next, write domain, codomain and range. Clear? So already we know domain, codomain and range. Clear? Codomain means the second set, the complete second set of A cross B. Clear? So here they have not given two different sets, but they have given only one set A, and they are defining the relation from A to A. The set itself is defining a relation. Are you clear? So relation is defined from A to A. Okay. So first let us solve this R. First you simplify R equal to, see, order pair x comma y such that y equal to x plus 1. Clear? Okay. So you have to simplify this. What is the first element? 1. Clear? So if I write 1 in the place of x, how much you are going to get? 1 plus 1 is 2. Clear? So that means in the place of x, if I write 1, y will be how much? 1 plus 1 is going to be 2. Are you getting my point? Next, in the place of x, if I write 2, what you are going to get? 2 plus 1, that is 3. In the place of 3, if I write, in the place of x, if I write 3, what you are going to get? 3 comma 4. Clear? In the place of x, if I write 4, y will be 5. In the place of x, if I write 5, y will be 6. Clear? In the place of x, if I write 6, y will be 7. But this cannot be written because the elements in the order pair has to be in the given set. See, 7 is not present in A. That's why I can't write this. Are you clear? I can write 1 comma 2. In the place of x, if I write 1, y will be how much? 2. In the place of x, if I write 2, y will be 3. By simplifying this, in the place of x, if I write 3, y will be 4. In the place of x, if I write 4, y will be 5. In the place of x, if I write 5, y will be 6. Here ends your relation. Clear? Next, first you solved this relation and you have written the order pairs. According to the question, what you have to write? You have to write arrow diagram. Okay. So first one, arrow diagram. So arrow diagram of this will be set A to set B. What is set A? 1, 2, 3, 4, 5, 6. What is set B? 1, 2, 3, 4, 5, 6. This is set A and this is also set A because there is only one set A. This is from set A to A. This is R. Okay. 1 maps to 2, 2 maps to 3, 3 maps to 4, 4 maps to 5, 5 maps to 6. See this, 1 maps to 2, 2 maps to 3, 3 maps to 4, 4 maps to 5, 5 maps to 6. So this is your arrow diagram. Are you getting my point? So now the first element is over. Let us go for the second one, domain. In the second one, domain equal to set of, see, the collection of first elements of your relation R. The collection of first elements of your relation R will be the domain. That is 1, 2, 3, okay, here only I will write. First one is domain. So domain will be equal to set of collection of first elements, that is 1, 2, 3, 4, 5. Clear? Next, codomain. Codomain means what? The complete second set. Here the second set is also A, first set is also A. That's why no problem. So codomain is 1, 2, 3, 4, 5, 6. Because they have given only one set for this problem. That's why the second set is also same, the first set is also same. So codomain will be 1, 2, 3, 4, 5, 6. Now range. Range is what? Collection of second elements. 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. Clear? So this is what your example 7 tells. Clear? The first collection of the first elements is domain, the collection of the second elements is range, and the set A, that is the second set. According to this, they have given only one set. If they give two sets, the second set will be codomain. The complete second set will be codomain. And the range is the collection of second elements. 2, 3, 4, 5, 6. Domain is collection of first elements. Clear? So this is how we can solve your example 7. Clear? Okay.